Okay, so my name is Rino Montiel. I run the core engineering team at EyeEm, and I'm going to be talking about building scalable infrastructure for deep learning applications. So EyeEm is a creative community and marketplace for real photographers. We target two audiences. One of them would be sellers, people who upload photos for our platforms and want to sell them. And other one is buyers. And we solve different kinds of problems and build different kinds of applications to support their different use cases. And we're driven by a mission of understanding photography. When I say understanding photography, we want to understand the content of photographs, and we also want to understand the quality of the photos themselves. And we also want to understand the industry, the photographic industry as a whole. To do this, we do deep learning. The reason we do deep learning, to explain the reason why we do deep learning, I have to explain a bit about why traditional machine learning doesn't really work for these problems. With typical machine learning, you would have a problem that you can describe the solution for very easily. For example, you could say you want to predict the house price, and you have a certain set of rules that would tell you how much a house would actually cost, for example, how big is the house is, how big this room is. And you can describe the solution to the problem very easily. Whereas with visual understanding, when you see a photo of a cat, for example, you cannot really know what's happening in your brain to know that this is an actual cat. So if you're tasked with a problem, which is understanding what's inside of a photo, you cannot really describe the solution to this problem. And this is why deep learning is so powerful, because you can train models to solve these tasks without actually knowing how to describe the solution for these problems. In our case, we work with real photography. So we have around 80 million photos so far, and you see all sorts of content. You see good photos, you see bad photos, you see photos of pretty much any type of content anywhere in the world. And we are trying to find the content or identify what's inside of each of these photos and how much quality or lack of quality these photo has. For this, we have developed several models to understand quality and content. The first model that we built was a concepts model that describes the content inside of photos with tags. I'm going to show you examples of the Jewish Memorial here in Berlin, where we have generated tags to identify what's inside of those photos. So with this photo right here, you see that you have abstract, concrete, and aesthetic concepts, which is very photographic specific. For example, you have diminishing perspective because you can see that the path leads somewhere, like a small dot in the middle of the photo. You have repetition, which is an aesthetic concept from photography, because you see all the blocks that are repeating throughout the photo. And you have more abstract concepts, like, for example, the machine has understood that this is the way forward, which is very interesting for a machine to learn, and very hard to describe or to solve with traditional machine learning methods. Here you have the same photo, and you can see how the model itself has actually recognized different things in this photo. For example, the fact that we have a man there alone, and it has described it as solitude. Yeah, also the sky and the copy space that you have above the photo, very photographic specific. And then you have a completely different photo with the same location, where you can see that the machine has actually recognized that this is a leisure activity. You see people hanging out and chilling in the Jewish Memorial, and the fact that this is a tourism shot is described with the tags. So this is the concepts model. We have also developed a captions model. The captions model gives you textual descriptions of the photo itself. It could be a sentence that describes the main subject of a photo. This is actually me on a photo walk we did a month ago. We went to an abandoned building, and you can see the description generated a machine, a man on an abandoned building. Here is in our office, one of our colleagues' portrait of a young man. It not only recognizes the subject of the photo itself, it also recognizes the style of photography itself. So you have a portrait and a young man identified. The funny thing about machine learning and deep learning is that it's not 100% accurate. So sometimes you have to validate these models, you have to put a lot of effort, and because sometimes you find things like this, for example, which is woman photographing through a smartphone. No woman, no smartphone, no nothing. So you really have to pay attention into validating these models. So now we have a clear understanding of what's inside of a photo. The next thing would be, how do you identify the quality on photos? And for this, we have developed the aesthetics model. There's a link right here from our head of R&D, Apu, which describes it. But in a nutshell, aesthetics is a model that gives you a rank of how beautiful or visually appealing a photo is. And this is very powerful for many applications. Simple example is search. If you search for portrait on a platform and you sort it chronologically by the most recent, you can see that you have different types of photos, which might not necessarily be ranked from the highest quality to the bottom. For example, this photo right here in the middle is a bit distorted and pixelated, which you might find the right content, but you don't find the content that you actually want. You don't find that perfect photo. Once you sort it by relevance, our aesthetic algorithm boosts the best results to the top. And you can see that the quality difference is completely different. So now I'm going to dig a bit deeper into which products we have built on top of deep learning at EyeEm, and how the whole architecture that we have built has evolved to allow us to solve these problems. So I'm going to talk about search, which was the first product that we built, finding the perfect photo. As a buyer, if you want to buy a photo, you want to find the perfect one. You don't want to have to scroll through all these photos to find the right one. I'm also going to talk about tagging, how we help photographers tag their photos automatically. Photographers spend way too much time tagging photos themselves. They spend hours preparing photos because they want to have their photos be discoverable by search. And this, we can do it in an instant. I'm also going to talk about the role, a new product that we launched back in May, where we take these models and we apply them on the camera rolls on the phone to organize everyone's photos on their camera roll. And then I'm going to talk about something very specific to the photography industry, which is a photo review process. When you want to sell a photo, there's a lot of things that happen behind scenes, and I'm going to talk a bit about how we actually optimize this workflow and build models to understand the commercial value of a photo. So in the case of search, finding the perfect photo, we needed to build an architecture that allowed us to do offline classification and ranking. Doing search, you can go very far without deep learning. For example, you can have location-based search. Here's a search of Berlin Mitte, and you have relevant results right there. But what happens, you can also do, for example, color extraction, and use the tag that the user describes the photo with to find sort of relevant content. For example, a yellow flower on a dark background. You just need to extract the colors, use the description that the users put in, and then you have the right content there. But what happens when you want to do search for something a bit more abstract, like, for example, happiness? Happiness is not something that you can easily describe with traditional machine learning, but when you apply these deep learning models, you can have not only the right content, people obviously having fun or being happy or smiling, but you also have the best results with aesthetics built on top. So the basic architecture is quite standard. It's a publish-subscribe model. Photos comes into the platform. We have a photo ID. The photo gets uploaded to S3. And then we have a service which we call Cafe API. We, in the beginning, started using Cafe as a deep learning framework. And this service then run the concepts and aesthetics model, stored the results, and provided the results through an API. The average model processing time was 1 second. This is not very performant, but in the case of search, you don't really mind so much if a photo gets indexed in 1 second or in 10 seconds, as long as it's searchable afterwards. In this case, another photo that we took during a photo walk. These two guys right here with the really scary masks are the guys actually building these models and bringing them to production. So we were actually, you can see that you have cloudy background, you have a building, you have the sky, and you have a sunset. So towards the end, the way it looks is we have the photos coming in. Cafe is subscribed to the exchange, to a routing key that includes the photo ID, and then once we rank the photo and classify it, we pass another message to the RabbitMQ, and the photo gets indexed by search. In this case, the aesthetic rank was 0.04, which in our case, we have a -1 to 1 rank, which meant that this photo is slightly above average, which is pretty good. So now we have solved a buyer problem. You need to find the perfect photo first. Then we went to solve photographer problems, like tagging. With tagging, we needed to build a slightly different system. We needed to build a system that allowed you to classify any photo on demand. So far on search, we were classifying photos that were part of the EyeEm platform. We had a photo ID for this photo, and everything was bound to EyeEm. But as I said in the beginning, our mission is understanding photography as a whole, so we don't necessarily want to restrict ourselves to the EyeEm corpus. So we built 2 features. One of them on our website called the Web Upload Tool. As you can see right there, we have tags suggested before they go into EyeEm, which means that we don't have this entity on our platform yet. We also build this into our clients. So before you upload the photo, you get suggested tags that tell you, that describe this photo, which allow the photos to be more discoverable and also searchable, which means that if you want to search, if you want your photos to be found by buyers, you need to describe them properly. And we suggest this on demand before you upload the photo. So obviously, running all of this on one service didn't really cut it, so we had to be pragmatic and actually decouple this. So we moved the concept and aesthetics calculation of Cafe API to its own service, and we moved everything that was EyeEm specific to a separate service. The average processing time of 1 second was okay for this use case in the, when we launched it. So very similar architecture. The only difference here is that we have a file ID that basically is a key to an S3 bucket from where the Cafe API service can actually pull the data from and then serve the results to the front end. So far we have solved buyer problems, we have built architecture to do offline classification of photos, and we have built on-demand classification of photos to solve the tagging use case. So now I'm going to talk about another problem. So we have all these models that can help you organize photos. So we wanted to solve the problem on your pocket, which is the photos on your camera roll. Everyone has a mess on their camera roll, and organizing this is a big problem to solve. So with the roll, we run the two models, aesthetics and concepts. We can organize by concepts, so meaning that your photos are searchable, and we can rank the best photos. So you can actually get the best photos as soon as you go into the app. You can find the best photos from last week, for example, or the best photos on this location. Here you can see how we applied aesthetics and concepts on this screen right here. The aesthetic score has been mapped from the -1 to 1 to a percentage, and then we have the keywords that describe the photo. Another challenge from this was that we didn't know what reception this was a completely new app. When you're launching a new app, you don't know what the reception is going to be. You don't know if you're going to have app features on the store. You don't know what sort of articles are going to come out there. You don't know which traffic you're going to get in. So we needed to plan for capacity and throughput. So now I'm going to talk about the changes we did to the architecture to support this use case and to solve this problem. So if we come up with a very artificial scenario for this type of app, assuming that you have 1 million downloads a month, and there are, on average in the world, 1.5K photos per camera roll, which is completely made up number, it's just a gut feeling. That's like 1.5 billion photos a month. That's a lot of photos, and you need to plan capacity to support the best case, which is high throughput. So a trimmed down version of the architecture that I showed you before can already start, you can already start seeing some foundation problems in regards to performance and also stability. First of all, uploading and downloading from S3, it's between 200 and 300 milliseconds of added latency. That's the first thing that we needed to get rid of. That's huge overhead that we could not support. Also, the experience of the roll is based on the fact that your photos get indexed as fast as possible. So this was a major issue for us. We have a single point of failure with RabbitMQ. Our publish-subscribe model is based on RabbitMQ exchanges. RabbitMQ is super performant, but you cannot really scale it horizontally, which means that if we could get rid of this part, we would be safer in regards of reliability. Then also, there's the fact that our models took 1 second per photo per model, which meant that every photo would take only processing without all the overhead, 2 seconds, running aesthetics and running concepts. And the fact that our service on the edge was based on EyeEm, which is authentication. Just so you know, the roll is an app that you can just download. You don't need to sign up for anything. Your photos immediately start syncing with the servers, and it's free, and everyone can just download it. So there is no sign-up process. There is nothing. So as you can see here, we have some potential problems on the edge as well. So the biggest problem for us was the average model processing time. So the R&D team who builds these models actually came up with a breakthrough, and our internal tests proved that we had new models that performed around 50 milliseconds. Once we deployed this to AWS, we saw that because the GPUs are different, the average model processing time was 200 milliseconds as opposed to 50 milliseconds. So this is something that everyone who builds deep learning models should always keep in mind, that the graphics cards obviously are different. The GPUs are different. But we wanted to bring this a bit down. 200 milliseconds was still a bit high for us. That would meant 400 milliseconds only processing each photo on the model itself. So we did batch inference with the R&D team. What this does is effectively taking, instead of putting one photo at a time from CPU and moving the network over to the GPU, one photo at a time, we take a set of photos, we put them all on the GPU, the network is replicated on the GPU, and you save this step from CPU to GPU, and has huge performance gains. You can actually check the paper, which has some benchmarks that tell you how performant it is. This is obviously a bit different once you launch it on AWS because the GPUs are different, but we also had huge performance gains. This is a screenshot of the NVIDIA SMI tool, which tells you the utilization of the GPU. You can see right there that the volatile GPU utilization is 98%, which is super cost efficient. And with this, we also managed to bring down the average model processing time to 100 milliseconds from 200. So we went from 1 second to 200 milliseconds, and from 200 milliseconds to 100 milliseconds. So after you have 100 milliseconds per model, this allows you to do a bunch of different things. You don't want to make HTTP calls that take 2 seconds, which is why we were doing RabbitMQ. Once you have 100 milliseconds, the possibilities are bigger. So you can, for example, start getting rid of RabbitMQ because you can make HTTP calls. If you're making HTTP calls and passing photos from the clients to the server, you don't need S3 anymore. So the only thing that was left for us was refactoring the Cafe API to take these requests and building a new edge service that would not require EyeEm authentication. And this is what it looked like in the end. Way more simplified and way more performant. What happens is we have the role API, which takes in photos from the clients, batches them, and then flushes them to another service that we called Espresso, because it's faster and stronger than Cafe API. And once this is classified, we take the array of concepts and aesthetic scores, and we return them to the role API, which in turn returns them to the original connection. So each client gets the rank and the concepts per each photo. This is what Espresso looks like internally. We take a batch of photos in. We built a gatekeeper actor that manages the amount of work on the GPU, because you don't want to run out of memory and you don't want to process too many batches at the same time, because then the GPU, you have performance degradation. So we measured manually what the capacity of each GPU on AWS was, and with this we can say the server has too much work. We return a 429, which allows us to do 2 things. First, the clients can retry. If we have too much capacity, we don't have enough capacity, and we're auto-scaling, for example, then the clients can retry afterwards. And again, we can also send the 429s to CloudWatch, for example, and that allows us to do some auto-scaling based on the load on the GPU itself. If the amount of work is okay, then we can actually run the deep learning models, we subtract the batch size, and then we give a 200 response. So after doing all of this, we launched the app, and we were doing around 900 photos per second, which was more than we actually estimated in the beginning. We had no downtime, and we had no degraded performance, which was a major success for us. So now we have had offline classification and ranking. We have on-demand classification, and we have built a system that has high throughput, that supports high throughput, and it's optimized for performance. So now the photo reviewing process. This is like the behind the scenes of the photography industry. For this, we needed to build a system that was flexible as well, and I'll mention why in a second. Because one thing that people don't know is that selling a photo is not straightforward. I take a photo of here, of this scene right here, and there's a bunch of people that can be easily identifiable, which means that I have to get model releases. People need to release this photo to me. I cannot just have a photo that someone puts in the platform and then start selling it, because there might be legal consequences of that. Or the fact that this is a property, or there is a logo around here that's intellectual property, we also need to identify that. Currently, the industry reviews photos manually. If you go to any of these platforms, you have an army of reviewers going through each photo manually and saying, this needs a model release, this needs a property release, and then the photographer gets its feedback days or weeks later, and they just have to come up with a way to solve around it. This is just a visual representation of what a normal photo reviewing process looks like. You have photos coming into the platform. In our case, we have tens of thousands coming in every day with varied quality, and the keywords before going to sale need to be keyworded and captioned before. So you have armies of people reviewing quality, armies of people reviewing legal constraints, and you have armies of people keywording and captioning photos. Plus, the user experience is completely ruined, because the more photos you have on the platform, the more people you need to hire, and then you have, you have photographers waiting for days until they can get their photos up for sale. So we developed more models. a quality score, well, something we call the quality score, which can predict the commercial viability of a photo, how valuable a photo is commercially. We can now detect also model releases, how many people are inside of a photo. And we can also detect landmarks and logos. So with this, we increase efficiency across the board. If the photos come in, we have the Espresso service running these models, and Espresso can detect whether a photo needs more releases, high quality, low quality, and already captions and keywords the photos. We only do manual reviewing when the confidence of these models is not enough. We also have a confidence score built into the models. So when, for example, you have a cat playing a piano down the street, which is a completely unusual photo, the model hasn't seen this before ever on the training data. It's not confident that this is actually right. This doesn't make any sense to the model. And then we have human reviewers actually reviewing the photo, but the load is way less. So back to the flexibility, we have many models, many versions, and many applications. This is a potential problem as well when you're building deep learning, because you have a specific input that your models require. For example, in the case of the role, you have an application that sends photo to the server from mobile. These are very small thumbnails. But what if you want to have a different model like the quality score, which takes in a bigger photo? You need to support this as well. And if you build something like an application like the role, and you build client-side search based on the keywords that you get, if you have a new version of the model that changes this, you don't want to ruin your client experience. So we needed to have an infrastructure that would be able to put up different types of stacks with different model versions on demand without having to do much work. Also allowed us to be more efficient internally when launching new deep learning models. So this is what we did. We changed Espresso. So Espresso effectively became a coordinator, and then we had different stacks where we can plug and play different model versions. So we have so far aesthetics, concepts, quality score, and captions. But this is all about, so far we have talked about content and quality, but you might argue an aesthetics score, an universal aesthetics score, how is that identifying beauty? Because as humans, we don't really agree on what's beautiful and what isn't. You might see a photo that you think is really cool, but I might think that it's ugly and vice versa. And you would be right, because beauty is subjective. Also, symbolism is subjective. What you might need as a company, for example, if you're launching a new campaign, might be completely different than what we want at EyeEm, which is kind of cool street photos. So for this, we solved it by doing personalized aesthetics. Building a personalized aesthetics model, you can take photos in. We take photos, say, a bunch of photos that you like, and then we train a personalized model for each application use case. And this is how we solve the aesthetics problem, because we can disagree about aesthetics, and that's totally fine. Just like every company can actually disagree on what symbolism they want on their medium. So we have billions of photos created every day. We have more photos created every day than the whole history of mankind before the invention of the smartphone. Which means that to organize all of this, we need to build systems that can understand photos and then can scale very well. And so far, we have talked about understanding content, the visual appeal, either personalized or not, the copyright or permission issues on commercial photos, and the commercial value of photography, which gives us a bit of understanding of the industry itself. And we have built systems that scale, like with the role, that do classification and ranking offline, that can do on-demand classification, and are very flexible when launching these models. And we have solved all of these problems internally at EyeEm for our different audiences. So far, by using and building all of this and having all this capacity with these performance systems, the next step for us naturally was to offer these APIs for other companies and other brands to come up with their own solutions to understanding their own mediums. And with that, that's my talk. And thank you very much for listening.
Thanks a lot, Rino. Questions?
Questions?
How much manual input do you need for building these models? Because I have, for the role app, for example, there's no way of actually giving feedback of whether this worked or was right or wrong. Yeah. Is this something that would help you and that you were, or that doesn't make sense at all?
Yeah, well, in the case of the role, we're talking about your private photos. So we don't really store anything, and for privacy reasons, we really don't want to use these photos for training. We have a community that has shared 80 million photos, and that gets us very far. And there are other ways to get data sets, there are also public data sets. But in the case of the role, privacy is a major concern for us, and we don't really want to have anything to do with people's private photos in that sense. Yeah.
More questions? I actually have two. Oh, okay.
Thanks for the talk, really inspiring. Is it open source? How would it cost to build it from scratch?
To build what from scratch?
Espresso or your system?
Yeah, so we're always deploying new open sourcing some components. I'm not sure how much it would cost to build. I haven't really run those numbers. I mean, it's taken a few months of work doing all of this, so we need to actually sit down and calculate everything. But
I mean, you use Cafe and some.
yeah, well, we used to use Cafe, now we use Tiano, but Keras and Tiano. But yeah, I mean, the system supports every type of library. So the supporting libraries that we use for our use case, we always try to open source them as much as we can.
Any more? Are you offloading any of the processing on the device? Do you do any kind of pre-processing or of the images or of the models on the device itself? Or is it you just take the picture and you put it on the server?
Yeah, currently on the roll, some processing happens on the device when it comes to resizing. Because the roll, you don't want to saturate in a mobile network. So we optimize the model to take small thumbnails that are like around 200 pixels wide. And but we have developed some on-device models that we can potentially use in the future as well.
Okay. And the second one, like, do you see any common kind of patterns or mistakes? Basically, you build a model like as a research model, like it works on my machine kind of, and then you want to scale it to work with millions of things. Like you have done this a couple of times. Do you see any things where you fail every time? Like you mentioned processing, like the time it takes to process. Any other things that are important?
Yeah, I mean it's there are also sorts of things, and they also depend on application, and that's why I was referring to the flexibility that you need to have on the platform. Because each application has their own set of rules. And for example, when you have an application like the roll, and say we build an aesthetics version, if this version, for example, starts punishing black and whites, which are very artsy, in the case of the roll that is a consumer app that everyone's using, you don't want to do this. Whereas if you have, for example, your own individual search, but you might only see this in production because you have tons of millions of photos happening and reports start coming in like, oh my God, doesn't make any sense, it's a aesthetic score. So these are the sorts of things that you only see en masse when you actually launch these things, plus the performance issues that are always prominent when you move from your own machines when you're training to cloud-based GPUs.
Two questions also. One, how did you train for aesthetics? What was your input value, your training label there?
So for aesthetics, so we have at EyeEm a ton of photographers, professional photographers, people who love photography, who help us organize this data set and bring up the aesthetic quality and validate and label this training set. Yeah.
Okay. And did you have to do a lot of tweaking of the actual structure of the neural networks, or is it more or less that what you find from the books? Is also questioning here if we would start doing that? Would you say you need to change a lot, or is the state of the art so far that it just works? If you have enough data to train it.
I mean, we do have enough data to train it, but of course, we're talking about a medium that can represent that is a representation of everything, right? It's visual. I'm not an expert on how much you actually need to tweak the weights of these models, but for sure, there's a lot of training data that you can use, especially when you're talking about a community that is all about photography.
I was curious about what you said before, that it can happen that you might send in production a model that starts penalizing, for example, black and white images. How do you make sure that the model that you put in production at the moment doesn't drift? Or is there any evaluation metrics? Because it could be that the scores for classification is perfect, but in practice what you get out is crap, right? Because it's bound to different metrics.
Yeah, but I mean, the accuracy of the model, like I said, we have photographers that work with us directly, and they do the validation.
No, what I mean is there a feedback loop that allows you to bound directly the click-through rate that you get on the website or something like that with the accuracy of the model?
Yeah, but that's not model specific, that's more product specific, and then we tweak depending, because for example for search you have click-through rates, you have funnels depending on how much you can actually sell, but for example in the case of the roll you cannot do something like this because these are private photos. So we don't really have like an automated system in place for one specific model because we have different versions. So it all depends on the product itself.
Okay, then thanks again, Rino.
Thank you.